Hello dear students, thank you for continuing your journey with pen and paper chemistry. We are going to continue with our topic of phenols, and this is going to be hopefully the last in the series of videos where we have been talking about a lot of properties of phenols in the series of videos. And this beautiful chart has been our mentor, our guide, while writing the reactions for the preparation and properties of phenols. So let's take up the miscellaneous reactions in this video. So I would expect that by now you know how to use the chart that I have shared. Now looking at the chart, please try and complete the reactions which I have listed over here for you. The first one is phenol with zinc dust on heating gives you what? It's an important hydrocarbon, an aromatic hydrocarbon. Can you write the product here, please? Second, phenol with ammonia. Now, although we know that phenol usually does not undergo nucleophilic substitution reactions, but we know that yes, it does react with ammonia at a temperature of around 300 degrees Celsius to give us an important compound. What happens to phenol in the presence of oxygen? We know that it gets easily oxidized. The color also changes. Otherwise, it's supposed to be colorless, oily liquid. But what happens in the presence of oxygen? Why does it turn brownish when left exposed to air for a long time? The last reaction, phenol with neutral FeCl3. This reaction is a very important test for phenols, which you are also going to carry out in the laboratory. Please write the products of this reaction, and in case you do not have this chart, I have already shared it as the first video in the series of videos on phenols, and also explain to you how you can use this chart. So please make sure that you derive maximum benefit out of it. Okay, coupling reaction. How many of you know coupling reaction? Please raise your hand. Okay, this is with diazonium, benzene, diazonium chloride. You remember N2 positive, Cl negative, and phenol. I want you all to be able to complete this reaction and give me the products. What are the products of this reaction? What is the condition of this reaction? What is the IUPAC name of the product formed? We've done all of this under diazonium salts. And I can see that many of you have taken advantage of the video on diazonium salts. So please write the product, write the structure, the name, the condition of this reaction. And don't forget that this reaction is a very important test to identify phenols in the laboratory. Phenolphthalein, a very, very important indicator for strong acid, strong base, or weak acid, strong base titrations in the laboratory. And hopefully now with the schools opening up, you will get a chance to do these titrations in the laboratory. Phenolphthalein is a very interesting acid-base indicator. Can you tell me what changes phenolphthalein undergoes in acidic and basic medium? Now let's see how phenolphthalein is prepared in the laboratory. Phenolphthalein, if you see, I've broken it down into two parts. Phenol, so that means it's a compound of phenol. Phthalene comes from phthalic anhydride. Now this phthalic anhydride, I'm going to go to it step by step. Phthalic acid here is benzene 1,2-dicarboxylic acid, right? You see there are two COOH groups on the benzene. So benzene 1,2-dicarboxylic acid. Bring about its a dehydration. That means remove water from it and we get here phthalic anhydride, the anhydride from phthalic acid. That means when you remove a water molecule from phthalic acid, it gives you phthalic anhydride. These are my easy ways of remembering things which I am sharing with you. Now, what do we have to do is we have to react phenol with phthalic anhydride. So let's do one thing. Let's move these here for easy usage. Have you noted till this? Because I am now going to play the next easy trick. Now what I'm going to do is I'm going to put the hydrogens here. These hydrogens are part of the benzene ring, which we've not been showing till now. Now see, we had removed one water molecule. Now what we are going to do is, look at this. What are we removing from here? Yes, we are removing a water molecule from here. Now, when you remove a water molecule, what should the carbon do? It has to complete its 4-valency, right? Don't worry, I have not done anything great. I've just moved the two molecules closer because it was too big a structure and getting intimidating, right? So, phthalic anhydride, right, and phenol, they together undergo dehydration. Now when there is dehydration, means this reaction is taking place in the presence of a dehydrating agent, and the most common dehydrating agent that we know of is concentrated H2SO4. So they react and we get phenolphthalein. What I'm going to do is again draw the structure of phthalic anhydride. C double bond O, O, okay. Keep watching and then you can draw it yourself. Now if you realize this O is going away, as well as the hydrogen of the benzene ring. So the two benzene molecules, the two phenol molecules now, they will come towards carbon. Oh, you lost the hydrogen, you lost the oxygen and we lost the hydrogen. Why not make friends here? And in the process, they end up making a very, very important compound for us, which is known as phenolphthalein. It's not phenolphthalein, it's phenolphthalein. The L here is silent. Also, these are bonds between carbon and the remaining sad molecules of phenol. And in the process, all of them are happy, just like me and just like you, because we've completed this journey of the learning of phenols together. Stay safe, stay happy, and take a little break before you start your next video or your next subject. Stay connected while we continue with this.